Hi, this is my project for process turn-in 2. I'm going to start by going over my T1 data fit. So basically I started by putting all of my constants in here. As you can see, like they're all equations up here in this bar. So I just got these from the turn-in 1 formulas, and then from there I used the T1 fit equation for my turn-in 1. And then I separated it into two terms just to make it easier to calculate. Basically, I put in that equation that I had found. So like this one relies on a bunch of constants in there and time. And then that relies on that and like time and a bunch of constants. Then I subtracted this from like my fitted one from the actual one and then squared that, and then I summed that squared error down here. Then I used solver to minimize this while varying these guys, and then I also kept B1 between 0 and 6,000 liters, and then I kept QR above this QR min, which I just calculated from a formula from turn-in 1, just that it was more than the minimum flow rate. From there I had B1 and Q1, and I was able to use that. Okay, so this was my test run. Then I was able to use that in my actual run. Over here, change this. So I like brought over these two constants and then my UA value, because those were all going to be constant, brought those over as just constants, and then changed the effluent to 75 for steady state, and then calculated T2 and the UA steam temp, just from that UA equation that we found in turn-in 1, which I'll show in a little bit. And then it changed like all of these constants. Let's see, what else can I talk about with this one? I got a new steam temp, a new T2. Over here we have results. So this is my old T2 and my new one, and then my old TS and my new one. And then here are all of my constants. So the things that did not change when I changed from test to design was K1, Tau2, and KS. But other than that, all of them changed. And you can see that in a summary table right here. Okay, let's see. I'm now going to share my handwritten work. Okay, hold on. I just have to reshare. Okay, share. Oh, no. Oh my gosh. Of course it's not working now. Okay, perfect. So I'm going to show you my controller tuning quickly. I guess this is my UA equation from turn-in 1 that I used, and then I rearranged it down here to get TS. Or controller tuning, I did direct substitution. I got KC Ultimate and Omega Ultimate, and then I used Ziegler-Nichols correlations to get KC and Tau I. And here's my little block diagram from above. Got G open loop, plugged everything in, set that equal to 0 because it's a characteristic equation, and then subbed in S equals JW so I can separate into real and imaginary terms and solve for omega and KC ultimate. And then plug that all into Excel to get Omega Ultimate and KC Ultimate. And then from there, I did tuning. Here are my correlations. And then I got KC and Tau I. And then, oh, and then I went over to Simulink. So unfortunately, I can't share my Simulink screen because it will only run on the Alderson computers, and the Alderson computers don't have like a camera to video on, so that's cool. So here we go. This is my graph of all my data fits. They looked really good. My parameter summary, and then here's my Simulink model. I literally just used the one that we did in class and then like edited my values. So here's my PI. I like tracked that as well in my notes, just to get it into this form. And then here's my GB, my process loop, my disturbance, change function, yada yada yada. And then from the scope, I was able to get these results. So with the step, when we did a step input of 10 degrees, the deviation in the exiting tank 1 temperature, as you can see, it went from it was like at most it was 0. I mean, because I didn't add in the steady state. But the most it went up to was 2.3, so it was 2.3 degrees C. Let me make sure I've covered everything. Yeah, I think that that's it. There's a lot more details in my PDF I'm going to attach, so if you have any questions, refer to that. Okay, thank you.